5 to the x minus 3 equals 25 to the x minus 5. So this is our initial equation, and since the bases are not equal, we need to make them equal to each other. So that's what we're going to do first. So we know that 5 squared is 25, so we can change that base. So we would get 5x minus 3 equals 5 to the squared times x minus 5. And when you're changing the base, you don't just change the x, you also have to distribute, so that's what we're going to do. So when you distribute 2x minus 5, you distribute those, you get 2x minus 10. So then we would get 5 to the x minus 3 equals 5 to the 2x minus 10. So this is what we have now after we've changed the base. So now that the bases are the same, what we can do is we can get rid of the bases. So you get x minus 3 equals 2x minus 10. And then we solve from there. So we would add 10 to both sides. You get positive 7. X plus 7 equals 2x. And then subtract x from both sides. You get 7 equals 1x. So x equals 7. Okay, so that's our final. We did the work, so you can see we had different bases first. So initially we changed the bases to make them equal to each other, and we distributed both sides. That's how we got here. And then from there we got rid of the bases, since if you have the same base you can get rid of them, and then we set them equal, and then you just solve. Okay, next problem. Next problem. 5.5, number 33. So this problem is log 2 x plus log 2 x minus 2 equals 3. Okay, so first what you have to do is you have to condense them. So you'd get log 2 x times x minus 2 equals 3. Now, once you've condensed them, you have to put it in exponential form. So you would get x times x minus 2 equals 2 to the third. So then you solve for 2 to the third, so you get x times x minus 2 equals 8, because you know that 2 to the third equals 8. So then once you do that, you multiply, distribute these, you get x squared minus 2x equals 8. Now you have to put 8 on this side so that it's set equal to 0. So you subtract both sides by 8, you get x squared minus 2x minus 8 equals 0. So now we have to factor. So I'm going to do a factor x, triangle, whatever it's called, and I put negative 8 on top and negative 2, and I know that negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So these are our factors. So x minus 4 and x plus 2 equals 0. So then you have to set them both equal to 0. X minus 4 is equal to 0, plus 4, add 4 to both sides. You know that x equals 4, and the same thing here. X plus 2 equal to 0, minus 2, x equals negative 2. Now we have to solve for extraneous solutions. Make sure they're not extraneous. So first you put first we'll check for -2 first. So log 2 -2, that's not possible. And log 2 -2 minus 2 is log 2 -4, which is also not possible, which means -2 is an extraneous solution, which means x equals 4 is our solution. Okay, so this problem is from worksheet number 5, number 2. The number of students exposed to the measles at a school can be modeled by the equation a equals 10 to the e to the 0.15 t, where a represents the number of students exposed after t days. How many students were exposed after 8 days? So looking at this equation, I know that it's a population equation because it has to do with the amount of students being exposed to the measles, which means it has to do with people, population, which means the equation will be P of T equals PO base E R T, where PT equals the future population, PO equals the initial population, the R equals the rate, and T equals time. So in this problem, they give you the equation, so I'm going to show you like what each thing represents. So in this equation, A is what we're solving for, which is the future population. 10 is the initial population, which means it started with 10 students having the measles. E is just E. 0.15 is the rate at which students are being exposed to the measles, and T is the amount of time it'll take, and in this case, it'll take 8 days. So our equation is A, 10 to equals 10, which is students, E, 0.15 times 8. And now I can write the initial student, and this is the rate. Okay, so now we solve. So first you solve what's up here. So A equals 10 to the E, and 0.15 times 8 is 1.2. So now we have A equals 10 to the E to the 1.2. So now we're going to do E to the 1.2, which is 3.3201169. See, I haven't rounded yet. I'm going to round at the end. So now we multiply and we get 33.201169, which rounds to about 33. So looking at our answer, now we can say that after 8 days, 33 students will be exposed to the measles. And that would be our final answer. As it applies to the problem, we know that 33 students will have the measles after 8 days at the rate at which the measles are spreading in the school.